All right, so the big difference from chapter 8 into chapter 8 from chapter 7 is one of the things that kind of doesn't make sense why we do it for chapter 7, which I get. So with chapter 7, we're under the assumption that we know something about the entire population, but we want to guess that thing for just a little sample. Which the reason for that is like to see if your group is biased, to see if something's changing, like the vaccine, like they would test that against old data, is like chapter 7. But chapter 8 is we don't know what the population parameter is, so we have to use our sample data to guess it, which makes a whole lot more sense to actually use the way we think about it. So we are going to kind of do an intro thing here. What we're going to do is we're going to guess, like, I don't know how else to name it. It's the day of the month of your birthday. So like the number for the day, not the number for the month. So that's going to be somewhere between like 1 to 31, somewhere-ish there. For everybody, there shouldn't be any reason that it should be like bulked somewhere as opposed to others, which is why I wanted to use it. It's not a very big spread. And what we are going to do is we are going to take little samples around the room and use those to basically guess what our overall population day of the month of the day of your birthday is. So do you get the overall idea? Okay. So we're going to do groups of 4 just to make it easiest. I think I have this pulled up. Okay, so let's start with what our population is. So we're just dealing with our class. So what is our population? And technically it's just the ones who are here today because we're not including the ones who aren't, but that's not something we usually have to deal with in a typical year, and I'm fine with just writing this. This one's a little bit not as specific, but something about the quiz that's a little ticky thing. Our population is not Leonard's AP Stat class. What is the difference between me saying my 3rd period AP Stat class and all students in there? How is that different?
The population varies some days.
So what are my individuals when I write it this way? What are my individuals when I say it the other way? The class, and do you see the difference between that? So there's one thing that's on the quiz that I usually count off more for, and I only count off a point for it when y'all are writing it as like the whole thing instead of all the individuals in that whole thing. So I'll explain when we give it back. So our parameter of interest, and I'm kind of talking you through this because I'm telling you what we're trying to find. We are trying to estimate the true mean. And so y'all write this with me. What is our symbol for the true mean? What is our symbol for the actual overall mean? Mu, because it's for the population. I'm noticing a lot of stuff that people are getting mixed up, like they don't understand mu as a center. And they don't understand that standard deviation is a spread. And somehow I'm going to figure out a way to kind of have like a quick overview of like going over stuff like that. But like y'all are writing things where it says, like somebody correctly will say, as my sample size increases, my standard deviation decreases, and in the same problem you write, so the spread increases. You just told me the standard deviation decreases. It's like y'all don't make that connection at all. So, like I said, I'm going to find a way to kind of organize stuff to make sure that I can do like a quick rundown for people who are getting confused with stuff like that. All right, so we're doing an estimate of the true population mean U, which we're going to call day of the month of students' birthdays. So we're dealing with a mean. We can deal with proportions, but we're gonna deal with mean. And what we're considering success or what we're measuring is the day of the month of birthday. Now the given part, I'm gonna have to find out everybody's numbers and then come back to it. So just don't worry about that part right now. And then you've got this first thing. And I want to write some labels here. So the first one I want to be N equals, what does that mean? Sample size. This one's gonna be X bar equals, and what is that? Sample mean, and then we're gonna write something else there. So the very first thing that you need to do is, we're gonna be in groups of 4. Most of you are in groups, like I'm gonna rearrange it to where you're gonna be groups 4. Like you don't have to really move. Like so this 4 will figure out what their average is. That 4 will figure out what their average is. We'll put you 4 together. So talk amongst your group. Group. What's your birthday?
25th. 20th.
Okay, there's our 16, 15, 21st, 16.
Yeah, like mine's
Mine's 15.
Okay.
20, 25. So, 7th? Yeah.
What is it? There's
What's
okay. You're right.
30?
2016.
So you're just finding your one group average.
Well,
N's 4, right?
Yeah.
No.
I don't think
You're all gonna hear each other and then.
I see our group 1.
Yeah, this is 4.
Yes. Y'all group 2. Y'all group 3. Y'all group 4. Y'all group 5. Y'all group 2. What or 4? 3.
Our average is 20.5.
With me in there. Because we needed all of the same number.
Oh, we're group
Did you hear? Am I?
1. Ours is 20.5. We're group 1.
0.5?
Yeah, 20.5.
What's group 2?
20.25.
I don't remember who group 3 was. Y'all group 3? What was yours? 20.25? So what was N?
4.
So the first thing I'm making is we are only dealing with the same sample size. What is that similar to that we've dealt with in chapter 7? With something we did over and over where all of them had the same sample size. Sampling distribution. So like when we made the dots over there for the quarters or the coins, all of them were with 20 coin flips. Whatever you do the sampling distribution, it's all the same sample size. So that concept kind of relays over. I think I'm gonna have to type in everybody's numbers to get the last thing that we need. Whoever's, you have your 4 numbers written down.
It's 30, 25, 27.
30, 25, 27.
No, 30, 25, 27.
What are your
15, 21, 16.
what are your 4?
16, 15, 12, 28.
16, 2, 3, 7, 8, 3.
So,
It's very common.
No, we don't.
alright, so I'm giving you that our population standard deviation is 8.8. So we just resolved that whole issue of we don't need to know about the population because we're guessing it, but now we have to know the population standard deviation. We address that issue later, but we're just pretending right now for some miraculous reason we know the standard deviation of the population, but not the mean. So our next thing is going to be what is the standard deviation of that group? Well, how do I find that? Well, how is that going to be really easy? When I have 5 groups, why does that make it easy? Because they're all the same. We're all using the same population standard deviation. We're all using the sample size of 4. So you should only have to find it once and write it down for all of them. And what do we end up getting? $4.4. Let's do 2 decimals, like 4.4 what?
0.
Okay. All right, so we're taking a step back here, chapters ago. I don't know what we're doing here, but I know that we're doing something with 68% and something with 95%. What do you remember about something with 68%, something with 95%?
Then 1 of this would be-
So this is within 1 standard deviation of the mean. This is within 2 standard deviations of the mean. Well, I now have standard deviation. So can I calculate how many is within 1? How many is within 2? So you're going to use, and you're going to only do your groups, and I'll write them all together because the math part isn't my concern. So if you're group 1, how do I figure out this number right here?
2 times, or 60 times standard deviation.
But 68% is just how many standard deviations away?
1.
1. And then so how do I get that?
Add it.
To what? Okay. Why do I have 2 numbers under 68?
That's 1 centimeter small.
There's your lower, there's your upper. Here's your lower, here's your upper. And this is within 1 standard deviation. And this is within 2 standard deviations. So mathematically, how does group 1 come up with this number?
Subtract.
20.5 minus 4.4, and then 20.5 plus 4.4. And then so differently here, I'm doing what instead? So I'm minus 2 of these. So this is like, just so that, because I say things and people at home can't see it. You're technically doing this number twice and subtracting it from your mean. And so you should get your group's whole line, and then we'll just read them all out. And what weird's gonna happen down here? It's gonna go negative. That's fine. Alright, so group one, my lower is what? Or my first lower is what?
16.1.
And then my upper for 68,
24.9.
and then my lower for 95,
11.7.
and
29.3.
alright, so let's have a very, very generic conversation really quick. Just kind of tying this in back from where we did this months ago. I am 68% that it's going to be between here and here. So when my confidence goes up, why do my numbers go farther away?
The biggest spread.
Because I'm more confident that the weather's going to be between 0 and 100 than I am that the weather's going to be between 95 and 97. So the more confident you get, the wider that range should be. So group two, what's my first lower?
15.85.
And
24.65.
then my last one,
11.45. 24.05. 29.
group three, what's my first lower bound?
15.85.
Oh, well, this is going to be easy because they're going to be the same.
Yeah.
Group four, what's my first lower?
3.35.
And then
12.15.
the next one,
Negative 1.05.
and
16.55.
5.
Yes, please.
And then my last group, what's my first lower bound? What's 11 minus 4.4? What's 11 minus 8.8? And then, yeah, I'll read them. So that gives us, now I think I went through 7 groups just because I don't know how many people are going to be here in all my classes, so I have to be able to make equal groups, so I have to leave it just in case. We took pretty small sample sizes, so there's going to be variation in there, that's fine. Now below it, I have a thing for 68% confidence intervals, so very vaguely, I think you should be able to see maybe groups 1 through 7. And then I've got like a generic setup for a number line, but we don't know what we needed for the number line, and I did that on purpose. I want to start with the 95%, the second one, because I want to make sure that our number lines are numbered the same way. So let's look back at where we started. What's the lowest number overall of all of these that I have to cover? Negative 1.05. What's the highest number I have to cover? 29.05. Okay, so let's see what? 29.3. Okay, thank you. All right, so maybe 0. 8, 16, 24. That might get me close. Starting here with zeros. Don't write this down yet. I'm thinking through this. Starting at this line, giving me 0. Going by 4 each way. Would that be close? I'd be under a little bit, right? So this would be 8, 16, 24, 28, and just need to go a little bit past. Does that sound right? Okay, let's do that then. So let's. All right, so we're going to draw these intervals for each group. So the intervals are going to consist of different kinds of dots and different pieces to them. So what's the first thing I have to go off of for your group? Your group's what? Like what's one number that could best describe your group? Your group's what? Your group's me. All right, so for group 1, what was my mean? All right, for group 2, what was my mean?
24.25.
Group 3, what's my mean? What's my next group mean? And then my last one. So right now, I have one dot that represents each group. That is my best guess for that group if I only had one number to guess. Now the next thing we're going to do is include our lower and upper for each group. And so I went ahead and started with my 95% confidence intervals. So make sure that you're on the right graph, whether you're like, we're doing these, let's go ahead and do these same dots to both graphs. It's easier for you to look at what's in front of you than it is for me. Right now, I purposely want the exact same number line, the exact same scale, and we've got the same dots for both of them because if we have one number to guess using each group, it's going to be that mean. Now, once you have that, then we are going to add more dots for each graph. So I'm going to start at my 68% now. So I now have 2 other dots that I know about that first line. So my group 1 with a 68%, it had a lower bound of what? An upper of, which means the ones below it are going to be like 0.25, less than that. Pretty close. That next one's the exact same. What's my lower bound for 68% for group 4? And what's my upper bound? For 68%? No, hold on, dot. Did I do 4 and 5 out of order? Oh, that dot's just a little bit low. And then my lower bound for group 5 is and my upper bound for that group. And then I also have a line connecting my original estimate dot and my lower bound and my original estimate dot and my upper bound for every single graph. So these are all individual pieces that we're going to end up talking about. The green dot is one thing. The pink dots, my lower, my upper is another thing. The blue dots, or the blue lines connecting them is another thing. And then I'm going to move to the next one to do my 95%. For 95%, what is my upper for this or what is my lower for the very first one? And with the upper of, so those are all pretty close, because they're only off by a quarter. Group 4, my lower bound is what?
Negative 1.7.
And then upper of,
16.55.
and then my last group, my lower is,
2.3.
and an upper of, and then draw my lines and connecting. All right, so I'm going to do a lot of talking today that's just making connections with what we just did. What we just did is pretty simple, I'm hoping. But that is the basis of essentially everything for chapter 8. So the things I'm going to talk about from here are just connecting that and kind of talking ahead. So like your drawing that you have on your paper, I want you to stop there for today once you finish these. So I want you, if I draw anything else on mine, you'll need to draw on yours. So what happens is, and kind of relating this to chapter 7, is we made these for the groups that you happen to be in, right? But I could make one for every possible group of 4 I could possibly make for this class. And get all of those possible ones up there. Now, some of them are going to be down here, some of them are going to be up here, and that's fine. So what this means, if you see right here, even with my 98% or 68% confidence interval, these don't even overlap at all. It's either in one of these or in one of these, and it can't be both at the same time. So what 68% is, let me actually figure out, so I've got it all in my calculator already. Our actual population parameter was 15.45. You don't need to write that anywhere. So 15.45 is going to fall about here-ish. Like I have mine at 16, but we're somewhere close to here. Give or take, that's probably closer to these. Well, 3 out of 5 is what percent? About 60%, which is pretty close to that. What percent have that within their interval? 100. Pretty close to that, right? So that's kind of the idea of where that comes from. What really happens is if we made every single possible sample for all the ones that there would be, 95 of them would actually happen to overlap with this line. If I made all the possible ones for here, 68% would actually happen to overlap and capture that true line. But we never know if we got good ones or we got bad ones. And this is a strange way to say it, but I had a professor last year, explain this in a way that I thought was the best. Imagine you walk into a room that is pitch black, and you have a little, like a little hoop. You know how you play the fair game where you throw it on and try to see if it lands on the thing? Whatever it's called. Like toss it to see if it lands there. Imagine you walk into a room that's pitch black and you toss it. You have no idea if it landed there or not. Now you know it either landed or it didn't, but we don't know if it actually did or didn't. So for each one of these we make, we're not saying we know it captured it or we know it didn't. We just know if we did it a certain amount of times, 68% of the ones that we made would happen to land on there. The rest of them would not. So had I not told you the 15.45, none of you would have known if your interval actually captured the true one or not. So like that's the big idea of a confidence interval. But that doesn't mean your interval is 95% correct That just means if I made 90, or if I made all of the intervals, about 95 of them would happen to capture. With me there, like that's the big idea that actually goes along with chapter 8. We're gonna write this down tomorrow, but since we're here, I'm just gonna mention these key terms. If you have one dot that's gonna estimate your whole group, that is this, which is a point estimate. You have 1 point to estimate for your group. Your margin of error is how much you could be wrong, which is what we're dealing with the blue here. Confidence level is this, which changes the width. And then your confidence interval is actually like if I were to write that number, comma, that number, that would be your confidence interval. So like those are the connections we're going to make with vocab tomorrow. But if you're with me to that point, I'm good with where we are for today. Any questions with stuff right now? Okay.